Hello there, here is Costas, Sierra Victor 3, Oscar Romeo Alpha, and the purpose of this video is to show you how you can detect common mode currents into coaxial cables. And I have set up here, I have a signal generator that is working at about 2.5 megahertz. The frequency is basically random. I have just chosen um, a low frequency so that it can be displayed in my low bandwidth analog oscilloscope. And the signal from the signal generator is going through this coaxial cable to all the way to here, which is terminated with a 50 ohms load, not connected to anywhere else. And I have here a split core ferrite transformer with just a single turn in the secondary that is driving a balanced active amplifier in this circuit. So currently I have connected the generator and enabled the generator. The output power is about minus 2 dBm and it's terminated with a 50 ohm load. I should be able to detect the signal here because the output of this circuit is going to the oscilloscope. But you see there is no signal here. Why there is no signal? Well, there is either an error here in the probe, or the probe is working perfectly fine. And in this case, there is no fault in the probe here. I have checked that, and I will show you why it works in the next few minutes. So what's going on here? Why don't detect any signal in the oscilloscope? And the thing is that we're talking here about differential currents. Differential currents are actually the currents that are flowing through the coaxial cable, the actual currents from the generator all the way to the through the coaxial cable to the load. And because this is a balanced magnetic probe, it cancels out these differential currents. The current that is flowing outside of the coaxial cable is equal to the current, equal but different polarity, let's say, to the current that is flowing inside the coaxial cable. So the probe and being balanced and the amplifier being balanced, these currents here in the probe really cancel out, so we detect no signal at the output. And I would like to show you that this does not depend on SWR. So what I'm going to do now is I'm going to remove the load completely. And now that I have removed the load, again you can see there is no signal. There is now a SWR through the cable because this is not terminated at the destination with a 50 ohm loads, but we see no differential currents here. No differential currents. So the next experiment that I'm going to do is to be able, with this same setup, to detect the differential current. To detect the common mode current now. So we see that the differential currents cancel out. So what I'm going to do is I have a short piece of cable here connected with an alligator clip to the braid of this coaxial. Currently this cable is not connected anywhere. Okay, so what I'm going to do now is to connect this cable with the central conductor of this generator, and of course removing this coaxial cable from the generator. So I'm going to do it now. I'm going to remove this from the generator, all right, and connect this to the central pin. Right. Now the coaxial cable, I'm just keeping this with my hand for mechanical support, but the coaxial cable is actually now not connected anywhere. Here it is. Okay, just a piece of coaxial cable, and the only place that the coaxial cable is connected is to this single wire that goes to the central pin of the generator, and the pickup probe here really picks up the signal, right? And this is exactly the same amplitude signal as I would expect. So this is common mode current. This is common mode signal. Okay, it's picked actually from this probe because it travels at the outside of the coaxial cable, so we can detect it. So you see the amplifier is working perfectly fine. It's just that the differential currents before in the coaxial cable are cancelled out, but common mode currents that we see in these second experiments do not, there's no way to be cancelled out, so they are displayed, they're amplified and displayed. So that's a good way of demonstrating a common mode current, and it happens not only on the analog, you can see it on the analog oscilloscope or in the sampling oscilloscopes or in more modern oscilloscopes. It's just the same thing and at any frequency. So I hope this experiment was useful to you, and basically the reason that I've built this is I did this experiment was to verify that my circuit, my active amplifier here on the probe is really picking up the common mode currents and not the differential currents. So, success! I hope you find it interesting and come back for more videos. Here is Sierra Victor 3, Oscar Romeo Alpha. Thanks for watching.